Welcome back. Now, our game project is looking pretty good so far. We have our drone shooting those beams, but those beams are not really doing anything when they hit either a wall or anything else. So in this lecture, we're concerned with making those beams do something when they hit. Now, remember the beam itself is its own actor class. If we go into blueprints, we have a blaster beam folder with a BP blaster beam, and this is an actor. Now, it's a pretty simple actor. It just has a projectile movement component and a beam mesh, which is the root component. It doesn't really have a whole lot other than that. But we want this beam to do something when it hits some object in the world. I'd like it to show some special effects and perhaps disappear. Now, in order for this to happen, I'd like us to explore a new concept, the concept of hit events. You see, when the mesh hits something, I want to trigger some response. And in order to do that, our mesh needs to have collision information. You see, we don't typically use the mesh itself for collision. We use a more primitive shape, as that is less computationally intensive for our machines. So if I have my beam mesh component selected in the details panel, I can find the static mesh and I can browse to it and open up SM Blaster Beam to take a look at the static mesh. Now, to see the mesh geometry, I can go up to Show, and if I check Complex Collision, I can see what the mesh looks like. Each individual polygon makes up the mesh. As you can see, it's made of a bunch of triangles. And if we were to detect collisions based on this complex geometry, that requires a lot of calculations. Whereas if we used a more basic shape, detecting collisions with that basic shape would be a lot more optimized. And we can add collision to our mesh. This mesh doesn't have any collision, and we can know that by going to Show and checking Simple Collision. It's the same exact mesh as the complex collision. We want a more simple shape. Now we can add those here in the static mesh editor by going up to Collision, not this collision, but the topmost collision. And here we can add simplified collision volumes to our mesh. Now, they come in several flavors, and some of them are not appropriate for the shape we have. For example, if I add a sphere collision, we now have a sphere collision volume, and that's not exactly what we want. We want the basic shape that's closest to our cylinder. Now, I can remove that by going back up to Collision and selecting Delete Selected Collision. Now, if we chose instead a capsule simplified collision, this is a lot more appropriate. It is sticking out on the ends of our mesh, but that's not too big of a deal. If that were a big deal to you, you could use a different shape. I'm going to go up to Collision, and I can delete that selected collision. If you're not selecting a current collision, you can just remove collision. That removes all simplified collision. Now, the box simplified collision is pretty nice. It doesn't stick out at the ends like the capsule does, although it sticks out at the corners, so that's also a bit of a compromise. But these collisions don't have to be exact. In the case of our blaster beam, it's going to be flying through the air quite quickly, so we don't really need our collision to match exactly with the cylinder. All that matters for now is that we have collision. Now, as soon as we've added simple collision to our mesh, we need to go to our details panel and scroll down and find collision complexity. Now, this has to be set correctly in order for us to use our simple collision, also known as a collision hull. We need to use our collision hull by setting this to use simple collision as complex. This is an important step, otherwise our mesh won't be using our simple collision, so make sure that that's set correctly. Now, as soon as we do this, I want to show you a potential hiccup that you may face. And I'm going to show you that potential hiccup by going into my drone mesh, SM drone, and taking my sockets and moving them into my mesh, like this. into the rifles. You may have your sockets inside your mesh like this. Who knows? And if I go to show and show the simple collision for this drone, you may see that it has its own simple collision shape like this. Now that we're spawning something that has collision, we have to be careful not to hit that collision mesh on the drone. And if our sockets are inside the drone like this, well, let's see what happens if we go and simulate. As you can see, those blaster beams are colliding with the mesh itself. Now, we're going to learn more about collisions later, but for now, we're just going to need to make sure that those sockets are not inside the mesh collision for the drone. So make sure that those are out, not in that collision hull that the drone is using. I'm going to go into left perspective, and I'm going to change to wireframe just to make sure that these two sockets are slightly outside of that collision hull for the drone mesh. And now I can play test, and all is well. So for now, just make sure your sockets are not inside of the collision hull for the drone mesh. I'll go ahead and put this back to perspective mode here and close my SM drone. So now that we do have collision, we can close our blaster beam. I'm going to go ahead and save first. And we're done with that static mesh. And now that we have collision, we can configure our beam mesh to respond to hit events. So let's go to the event graph, and let's get our beam mesh onto the event graph. And dragging off of the beam mesh, let's type on component hit. Now we have a number of options here. You see, a static mesh component has its own event or delegate, and we can bind our own event to that delegate. Now, if we choose assign on component hit, a couple things happen. First, we're getting this node that allows us to bind an event to on component hit, which is broadcast whenever our component, in this case beam mesh, hits something. And it conveniently creates a custom event for us and automatically names it on component hit _ event. So what this blue node here is doing, as soon as the flow of execution reaches it, in this case in begin play, since I just connected it, whenever our beam mesh hits something, this event on component hit event will be executed. And once that event is executed, these output pins on the event will be filled in with data concerning that hit. So we have access to the information. The hit component will be the component that hits something, in our case, beam mesh. The other actor will be the actor that was hit, and other comp will be the component that belongs to that actor that was hit. And we have other information that we won't be getting into for now, but let's just see how this hit event works by getting that other actor and calling getObjectName on it. I'd like to print the name of the other actor as soon as we hit it. So dragging off of my execution pin, I'm going to get a print string node and hook in that object name. So whenever this beam mesh hits an actor, we'll be printing that actor's name just to prove that this hit event worked. I'll go ahead and remove these unused events, tick and actor begin overlap, so that we have a little bit cleaner of an event graph here. So I want to test this out. I'm going to compile and save this blueprint and go back to BP bot. And I just want to fire one single blaster beam. So for now, I'm going to bypass set timer by event. I'm going to break these two wires. And instead of setting a looping timer, I'm going to move those nodes down a bit and just call fire blaster beam once. So we just fire a single blaster beam. I don't want to get too confused by having a whole bunch of blaster beams just yet. So as soon as begin play is executed, the drone will fire one blaster beam, and that blaster beam is going to fire off on component hit event as soon as it hits something, and we should see a debug message. I'm going to go ahead and set the duration of this print string to 60 seconds so it doesn't go away right away. Now, before we test this out, I want to make sure that my bot is not rotating. So I want to disable my interp rotation function. I'm going to break that wire so that my bot does not rotate at all. I want it to stay facing its direction, and that way my blaster beam can hit exactly what I want it to hit. And to give it something to hit, I'm going to make another copy of my floor platform here. I'm going to take this top one, hit E to get my rotation gizmo, and hold Alt as I rotate it by 90 degrees to get a copy of it. And I'm going to move it out over here, and now we have a wall. So now we can go ahead and let our drone fire straight at the wall. I'm going to press play and test it out. Now we get our hit event, and check this out. If we zoom in, we'll see that our mesh has stopped in its tracks. That's because we're actually using that collision, and the collision is configured to be blocked by an object such as this wall. Now, we're going to get into collision in more detail later in the course. Looks like my beam mesh has met its lifespan and deleted itself. But now that we're getting a hit event and we have access to the actor that was hit, we can now do more interesting things like spawn particles and destroy the blaster beam. So why don't we do that? Back in our BP blaster beam, I'd like to spawn some special effects when our blaster beam hits another object. So I'm going to delete these two nodes and right-click and use Spawn System at Location. Now the system is going to be the one and only Niagara system we have, Beam Burst. But it would be nice if our beam burst were oriented according to the surface that we hit. Let's see what it looks like as is for now. We need to spawn the system, and we need a location, don't we? Now we could use the location of our blaster beam, but what would be more interesting is if we had the location of the hit event. Well, we can access the hit information for a hit event using this little output pin here called hit. If we drag off of it and release, we have the option to break this hit result. A hit result is a structure which is composed of other variables. If we click break, we can access those variables contained in this hit, and we can expand the dropdown to see all of them. So this little hit object contains lots of information pertaining to the hit event, including the impact point. The impact point is the point of impact. So we can take this impact point and hook it in to location. And now we'll spawn our Niagara system at that location. So I'd like to see how this looks, and I'm going to bring this wall closer so that we can easily see the result of the hit. So let's press play. Now, we didn't see anything, but I suspect that we are spawning that Niagara system. We just can't see it because it's not oriented correctly. Now we can prove that theory by moving ourselves just inside the wall here so we can see the other side and pressing play. And sure enough, I saw that Niagara system. It just happened to be spawned facing the World X direction. So we want to orient that Niagara system based on the surface that we hit. So I'm going to go back to my BP blaster beam and take a look at my hit result. One of the variables in the hit result is called normal, and as we see, it's a vector. Now, in mathematics, particularly vector mathematics, a normal vector to a surface is perpendicular, or in 3D space we say orthogonal to that surface. So don't confuse this with normalized vectors, which have a length of 1. Those are unit vectors. A normal vector, which is often a unit vector, but not always, is simply a vector that sticks out from a surface at 90 degrees from that surface. Now, we can use that normal vector to orient our Niagara system, but we need to create a rotator from that vector. Now, we can do that pretty easily. We can take this normal vector, drag off and release, and type make rot, and we have a number of functions that are designed to create a rotator from a given axis. And remember, if you're not sure which of these to choose, in Unreal Engine, always think of the x-axis for anything as its forward vector. So we're taking the normal vector and we're making a rotator from that vector's x-axis. That would give us the rotator corresponding to the vector pointing straight out from that surface. So we're going to use make rot from x. This returns a rotator, which we can pass into rotation. Now let's see what happens if we fire at the wall, and we saw our Niagara system. It exploded outward in the direction of the normal vector to the wall. That looks pretty nice. Now the blaster beam still survives, which looks kind of weird. So after we spawn this system, I think it would be a good time to simply delete this blaster beam. We can have it destroy itself. And if we right-click in the event graph and type destroy, we can call destroy actor. So after we spawn the system, we'll destroy this actor. Let's give this a try. And that looks pretty good. Now we can take a look at what this Niagara system looks like when hitting a surface that isn't straight upright. For instance, I can take this wall and rotate it up like this. And now if I press play and take a look at that Niagara system, it's a little hard to see because it's so quick. I'm going to move it out just a bit. Let's see what this Niagara system looks like at this angle. A little hard to see with it being so fast, but the Niagara system is oriented at an angle. So now I think we can go back to our BP bot and use our timer once again. So after storing the target pawn, I'll go ahead and set the timer like so, connecting those nodes, and going back to press play. Now we can see those particles and they're oriented at an angle according to the normal vector of the wall. Perfect. So now we have hit events and they're working for our blaster beam. Wherever our blaster beam hits something, it's going to spawn a system oriented according to the normal vector of the hit surface, and it will destroy itself, no longer relying on its own lifespan. And break hit results can be collapsed so that we can only see the top couple of nodes plus whatever else we're using on it. And that's a little bit neater. Excellent job, and I'll see you in the next video.